let's get to work. This is the review of your homework. This is Mr. Huff, by the way. Sorry I can't be with you today, but I'm going to be making this video for you that your sub will play for you in class. We're going to start with the homework, so go ahead and get that out if you don't have it out already. I'm going to be working through the problems first, and then we'll look at some review from Chapter 5. So right now we're looking at Chapter 4 homework. And if you missed this homework, I know I did post it wrong the first time. So if you didn't see that I changed it, don't worry about it too bad. Just make sure you get this homework done, especially before Friday, before we take our test. But if you don't have it done today, that's fine. No problem. Alright, let's get to work on number 1. It says if A equals 55 degrees and 55 minutes and C equals 16, find A. So what they're talking about is over here with the triangle, we have these letters. The big letters are going to represent your vertices, and then the little letters are going to represent your sides. So the vertices are also where we're going to have our angles at. So A is 55 degrees and 55 minutes. So we're going to have to change that into decimal version. And we know that C equals 16, and that's the hypotenuse. So that'll be the longest side. Alright, so let's change 55 degrees and 55 minutes into just degrees. So the way you're going to do that is divide 55 minutes by 60. So take this 55 here. How many seconds are in a degree? Or how many minutes are in a degree? 60. So when you divide 55 by 60, you're going to get the number of degrees that is. So 55 divided by 60 gives us 0.916 repeated. Okay, so with that, you're just going to add that onto the 55, so we get 55.916 repeated. Now for this question, it says for our final answer we just need to round to the nearest tenth. This is not the final answer, by the way. We've just found what the decimal version of this is. What we're trying to find is A. A is little a, so it's a side. So we will use this angle. We just needed to know the decimal version first. So in this case, when we want the nearest tenth, the numbers you're going to be using in your problem, you need to round them a little bit further if you are going to round them at all. It's always a good thing to not round if you can avoid it. But in this case, just to make it easier on ourselves, we will round. If you round 2 more decimal places than you need for your final answer will still be the exact same answer. Because you're not going to have any rounding issues if you go out to the thousandths place. Unless you're dealing with a whole lot of numbers. But in this case, we only have 2 different numbers we're looking at. So rounding to the thousandths place is going to work just fine for us on this problem. So we found the angle. We know the hypotenuse is 16. And since A is the opposite, and we have the hypotenuse, which function is going to represent the ratio of the opposite A over the hypotenuse 16? Opposite over hypotenuse. And we'll pretend like we're watching Dora today. So I'll just ask you guys some questions, and you can pretend to answer me, even though I really can't hear you because this is a recording. All right. So class, which trigonometric function uses the ratio opposite over hypotenuse? Very good. It's sine. So remember the SOHCAHTOA, SOH. Sine is opposite over hypotenuse. Alright, so with that, we do know the theta. The theta is your angle. So we can just put the 55.917 here. And I want to find out what A is. The way I find A is by getting A by itself. So we got to get that 16 to the other side. The only way to get the 16 to the other side of the equation is to multiply. So our A is going to be equal to 16 times sine of 55.917. Now you do need to put your calculator into degree mode for this to work. So whenever you're plugging in degrees in for your angles, you do need to have it in degree mode. So we're going to type 16, and then you can just put sine. You don't even need the multiply button. You can just put 16 sine 55.917. Enter. Now we know our hypotenuse is 16, so we should get an answer near that, because we know it's not going to be bigger than 16 because 16 is the hypotenuse. It could go down close to 0, but it's not likely to, especially since we have a 55-degree angle. It should be pretty close. And we do get A is equal to 13.251, and it goes on. So I'm just going to truncate it there, because we don't need to go any further, because remember we're rounding to the nearest tenth. So just look at this number and then ask yourself, does this number next to it round it up? In this case, yes. So A equals 13.3 would be your answer for number 1. Alright, so we do need to get rid of our work for the next problem because we're not using the same A, B, and C. We are using a different A, B, and C. We'll use the same triangle as a reference, but we will remove this portion for now. See if I can paste an image of that. Yeah, pretty good. We'll leave this over here on the side in case you want to look at that in the notes afterwards. Alright, so we'll get rid of that and plug in our new numbers. So we have A is 9. So A is 9 here. That's one of the legs. B is 49. The angle 49 degrees. And B is what we're trying to find right here. So we know we have the opposite and the adjacent. The only one we can use for in this case is tangent. Tangent of theta, because tangent is which ratio? What over what? Very good. Opposite over adjacent. Opposite over adjacent. So in this case, adjacent is the A, which is 9. And B is on top. To get B by itself, we're going to divide by 9. Do remember our theta is 49 degrees, so make sure your calculator's in degree mode still. It's not going to change unless you change it. Multiply by 9 to get B by itself, so we're going to get 9 tan 49. Type that into your calculator. you should get 10.353 and some other numbers. So ask yourself, does the hundredths place round up the tenths place? It does. So we're going to get 10.4 for our answer here. Alright, so we're going to copy this, make that our answer. B is 10.4. And we'll save this work. And move on to number 3. Number 3, we have 56.48 seconds. We'll need to change that into decimal. You just divide 48 by 60. 48 divided by 60 is 0.8. So this is 56.8 degrees. We have C, which is 63.1. Find B. Alright, so C is the hypotenuse. And we have B is the angle for 56.8 degrees. And we're trying to find B, which is the opposite. So we're using opposite and hypotenuse again. So we will use sine of theta, which is 56.8, equals the opposite over the hypotenuse. B over 63.1. So to get B by itself, we've got to multiply both sides by 63.1 to get sine of 56.8 times 63.1. It's going to be equal to B. Alright, so when we type that into our calculator, we get 52.8 when we round it to the nearest tenth. Always ask yourself, does that make sense? 56 degrees would keep it near the 63.1. So any of your degrees that are in the 50s or 40s or even the 60s, they're going to keep it pretty close to your given leg. Now when I say pretty close, it doesn't have to be within 10 or 20, it just needs to be a reasonable amount. So if we're talking like 90 is your hypotenuse, it would be likely that one of your legs is 60 or even 80, something near 90. But it can't be bigger than 90 because the hypotenuse is always the biggest side, or the biggest, biggest side of the triangle. So we'll move this to B. B is 52.8. Get rid of the work here. You guys already have 2 examples on the side to look at. I'll have this PDF posted on the classroom as well that you can look through. So number 4, if B is 64 degrees, that's this angle. So if B is 64 degrees and little b is 19.2, that's right here, 19.2, find A. So A is the adjacent, B is the opposite. So what trig function are we going to use, class? Very good. We're going to use tangent. So the tangent of 64 is equal to opposite over adjacent. So TOA we write opposite over adjacent. We have to keep that order. So we'll have B, which is 19.2 over A. Now, this is the first one we're running into where we actually have the variable on the bottom of the fraction. So the way this works is you have to multiply both sides by A, and then you're going to divide by tangent 64. So when you multiply by A, we get A times tangent of 64 equals 19.2. So the way we find A is simply to divide both sides by tangent of 64. So you're going to get 19.2 divided by tangent 64. Alright, and that's how you type it into your calculator. You'll just type in 19.2 divided by tangent 64, enter. So what I get on my calculator is a 9.36, which is reasonable. It's close to 19.2 when it comes to triangle lengths for sides. So that would give us 9.4 if I round it to the nearest tenth. 9.4 9.4 for number 4. I will save this work. So you guys can look at that again. Alright, and the last one for this section is 5. And we have B and A, and we're trying to find C. So little b is 14, that's this side. A, 16 degrees, is this angle. So B would be the adjacent side to that. And we're finding C, which is the opposite. So which function uses adjacent, excuse me, did I say opposite? I meant hypotenuse. So which trig function is going to use the adjacent side and the hypotenuse? Adjacent and hypotenuse. What do you say, class? Very good. Cosine. So SOHCAHTOA gives us CAH for ca, or for cosine. So the cosine theta in this case is 16. So since the angle is so small, our sides are going to be a little bit different lengths. But if B is 14, I'm going to expect that A is going to be pretty small. It still should be bigger than 1, but let's find out. So we're going to get the cosine of 16 is going to be equal to the ratio of the, actually we're not finding A, we're finding C, excuse me. So adjacent over hypotenuse, so we're going to get 14 over C. So actually, since the angle 16 is so small, 14 is our long leg, so the hypotenuse is going to be pretty close to the longer leg in this case. So it's going to be a little bit bigger than 14, so these numbers should be pretty close to each other. So I got to multiply by C again, so we'll have C times cosine 16 equals 14, and then we're going to divide by cosine 16 on both sides, so C equals 14 over cosine 16. You can type that right into your calculator. to give you 14.6 when you round to the nearest tenth. 14.6. So that's super close to the long leg, which was 14. So our answer for number 4 is going to be 14.6 for the letter C. Alright, and I'll leave this work up. Just know that this work does go with number 5. And what did we have? This one is number 4. And this one is number 2. And then this one is number 1. Alright, so that's how we have that work there. We didn't save the work for number 3. It's very similar to number 1 and 2. Alright, number 6 takes a little bit more thinking. It's a little bit of a word problem. We're doing construction. We have a 30-foot ladder. That's our given. So 30-foot ladder, that's going to be our hypotenuse in this right triangle. Right there. So 30 is our hypotenuse. It's leaning against a house, and it makes an angle of 70 degrees 5 minutes. So the angle right here is 70 degrees 5 minutes. How far up from the side of the house does the ladder reach? So how far up the side? So what's this distance from here to the ground? And then also, what's the distance between the bottom of the ladder and the house? So what's this distance? So we're trying to find the long leg and the short leg here. Let's do it one at a time. First thing we gotta do is change the minutes into degrees. We divide 5 by 60 to get 0.083 repeated. So we're just going to add that on to 70. So we'll have 70.083 repeated. We're just going to round that right there. Then we can use sine or cosine here, because we're trying to find the opposite and the adjacent using the hypotenuse. So cosine, we'll call this A, we'll call this one B. Cosine of 70.083 is going to give you the adjacent, which is B, over the hypotenuse, which is 30. And then sine of 70.083 is going to give you the other one, A, over 30, which is your opposite over hypotenuse. So let's split these up and work on them separately. You're going to multiply by 30. To get 30 times cosine of 70.083 equals B. So 30 times cosine of 70.083 gives you, to the nearest tenth, that's going to give you 10.2. Really rounding to the nearest tenth? I think we are. Alright, round to the nearest tenth. So since this is already in feet from your ladder, we're going to use the same units. So we are 10.2 feet away from the house. If we measure from the bottom of the ladder to the house, that is 10.2 feet. And then how tall up the house does the ladder get? Multiply both sides by 30, so you're going to get 30 sine of 70.083 gives us 28.2. Alright, so we're going to get 28.2 there. That's also going to be in feet. So the distance we go up the building, that A there, is going to be that 28.2 feet. And B, the distance from the house to the bottom of the ladder horizontally is 10.2 feet. Alright, so we would say, how far up the side does the house go? That is 28.2 feet. And then how far is the distance horizontally between the bottom of the ladder and the house? 10.2 feet. Alright, and then a circle is circumscribed about a regular hexagon with an apothem of 4.8 centimeters. Find the radius of the circumscribed circle. What is the length of the side of the hexagon? What is the perimeter of the hexagon? So forth. Alright, so there's a lot going on with number 7. Let me show you a diagram of what it's talking about. If we have a hexagon, let's see if I can make one that will look like a regular hexagon. Hey, there we go. Alright, so regular hexagon with an apothem of 4.8 centimeters. Alright, so your radius is going to be the distance from the center to the vertice. But we're looking for, or it tells us the apothem. So this would be your radius. This would be your apothem. It's your perpendicular from the side to the center of your shape. And if you don't remember that from geometry, don't worry about it. There's a lot of language in this problem that you're not going to remember necessarily. It says find the radius of the circumscribed circle. Circumscribed means it's going to be on the outside of the shape. Inscribed would be inside. Circumscribed is on the outside. So circumscribed is going to go around like that. Ooh, almost perfect. Just about right there. That's good enough for me. Alright, so the circumscribed circle is going to have a radius that goes around. We can find out what that radius is by using the apothem, because we know that the apothem is 4.8. We know that this right here is 4.8. We do know this angle. We do know this is a right angle because the apothem makes a perpendicular. So we're trying to find the hypotenuse, which is also the radius. Alright, so the reason we know this angle here is because it's a regular hexagon. Each hexagon is cut into 6 equilateral triangles. Equilateral triangles have angles that are 60, 60, 60. That adds up to 180. So if each one of these is 60 degrees, we're looking at this angle here. That is half of 60 degrees because we're not doing the whole triangle, we're doing half of it. So it's going to be 30 degrees. So we have our adjacent side and we want the hypotenuse. So which function is going to have adjacent over hypotenuse? Which of our trigonometric functions? Adjacent over hypotenuse, class. What is it? Very good. We're going to be using cosine. So the cosine of theta is going to be equal to adjacent over hypotenuse. So we can plug in those values. Theta is 30 and adjacent is 4.8. Hypotenuse, we don't know. We're going to multiply both sides by the hypotenuse. I'm going to shorten that just to h for hypotenuse. Or you could use r for radius. Multiply both sides by h, and then you're going to divide both sides by cosine of 30 to get hypotenuse equals 4.8 over cosine 30. And that's going to be 4.8 divided by cosine 30 is going to be 5.5 about. So we're going to call that 5.5. So what's the radius? About 5.5 centimeters. We're going to use the same units. What is the length of the side of the hexagon? Length of the side of the hexagon? Well, we have an equilateral triangle here. We know that this is 5.5. So this has to be 5.5. So that's the side of your hexagon, 5.5. Same number. And that's why hexagons are the best shape. There's so much geometry in them, and they're very easy to figure out because they have many rules. That's why bees love them the most. Alright, what is the perimeter of the hexagon? You just multiply that by 6. You're going to get 32.5 if you don't round. If you rounded to 5.5 and then multiply by 6. But if you go back to your original answer, which was 5.5425, you should multiply that by 6 because your actual answer is going to be 33.3 if we round to the nearest tenth. And that will be in centimeters because it is a perimeter. It's the distance around the hexagon. Alright, so that works. And let's move on to the next one. Observation. A person standing 100 feet from the bottom of a cliff notices the tower on the top of the cliff. The angle of elevation to the top of the cliff is 30 degrees. The angle of elevation to the top of the tower is 58 degrees. How tall is the tower? So does this look like a right triangle to you? No, it doesn't. So we got to find a right triangle. So there is a right triangle right here. Which is the one we're going to be using. So we have a right triangle, we have 100 feet. We're trying to find the height of the tower. We know that this angle is 58 degrees. So we are going to find the height from this point to this point. Now that's not the height of the tower. The height of the tower would be from this point to this point. So we do have to subtract this portion to to find the height of the tower. You can find that portion by using this right triangle with 30 degrees. They both have an adjacent side of 100. They're just going to have different opposite legs. So let's do the 30-degree one first. If we have the adjacent, we want the opposite, we're going to use tangent. So tangent 30 is going to be equal to the opposite over the adjacent. We'll call it OPP over 100. So I'm going to be multiplying tangent by 100. And we're going to have 30 inside the tangent function. That's going to give you 57.7 about. And that's going to be the distance from here to here, 57.7. Okay, we found that distance. Now we're going to find the whole distance from the ground to the top of the tower. From the bottom of the cliff, I should say, to the top of the tower. So we're going to use tangent again. We're going to use opposite and 100. 100 adjacent. All that changes is the angle. So we're going to do 100 times tangent of 58. That is going to give you 160. So 160 goes here. Yeah, let's put it over here actually. 160. So I have 160. If I subtract 57.7, that leaves us with 102.3, I believe. Yeah, 102.3. So the height of the tower is 102.3 feet. Alright, that's all we're going to do for that. And we're going to stop there for now. I'll have another video for you to watch for the review.